In this section, we will talk about a special type of recurrent neural network called long short-term networks or LSTMs. First of all, we have to talk about two problems of the plain vanilla recurrent neural networks. So let's get started. Before we start, first of all, we have to talk about two problems of the plain vanilla recurrent neural networks. So one of the problems is short-term memory. RNN suffer from short-term memory. So if we have a long sequence, then it is very hard for a plain vanilla RNN network to carry this information from the starting of the sentence to the end of the sentence. So if you're trying to process a paragraph of text to do predictions, RNNs may leave out important information from the beginning. So this is one problem of RNN, that is short-term memory. Another problem of RNN is vanishing gradient problem. What is a gradient? So gradient are values used to update a neural network weights. So during backpropagation, RNNs suffer from vanishing gradient problem. So this vanishing gradient problem is when the gradient shrinks as it backpropagates through time. If a gradient value becomes extremely small, it doesn't contribute too much to the learning. Just a little bit about why the gradient value becomes very small. It is because of the activation functions. So it is like our output lies on the flat areas of the activation function, which gives a very small value of the gradient, hence resulting in a vanishing gradient problem. So these are the two problems of RNN. But what is LSTM? So LSTM is a special kind of RNN that is capable of handling long-term dependencies. So as we talked about two problems, now we know that why we need a special kind of RNN called LSTM. But let's take a look again. RNNs turn out to be quite effective when dealing with small sentences, like for example if you're doing the character modeling or character prediction. So the color of the sky is dash. So if you pass this sentence to an RNN model, it is very easy for the model to figure out that okay, it will be blue. The next word in the sentence will be blue. However, in long sentences, the plain vanilla RNNs fail to understand the context behind the input. So one such example is like, I have lived in Spain for 25 years. I then moved to India. I can speak a variety of languages, but I am most fluent in. So if you pass this sentence to a plain vanilla RNN, it will not do a correct prediction. So if the person has lived in Spain for 25 years, then it is sure shot then he will be fluent in Spanish. But RNNs fail to capture this information due to the length of the sentence. So that is why we need a LSTM. But what exactly goes behind the scenes in an LSTM? I mean, we know that RNN has a memory and LSTMs has a special kind of memory that is manipulated through gates. So the memory or the cells are responsible for remembering the information, and there are two states that are being transferred to the next cell, the cell state and the hidden state. As we have already talked about that manipulations to the cell happen through gates, so there are a number of gates. So one of the gates is forget gate. Suppose you are capturing an information and now you decide that okay, it's enough, I have captured a long sequence and now you want to delete the information from the cell state. So we use forget gate that is responsible for removing the information from the cell state. Then we have is an input gate. So an input gate is responsible for adding information to the cell state. Suppose you are processing through the sentence and you realize that this is the information that is important and you want to keep this information, hence you will use input gate to add this information in the cell state. Now you have a cell state and you want to actually manipulate the cell state and find something out of it. So the job of selecting useful information from the current cell state and showing it out as an output is done via the output gate. So there are three types of gate. Every gate has its own functionality. So you just have to remember the forget gate removes information, the input gate adds information, and the output gate selects information from the cell state. But how this selection is done? How it is determined whether the gate is active or not? This is determined using a sigmoid layer. So the sigmoid layer outputs number between 0 and 1, describing how much each component should be let through. So this is just the basic functioning of LSTM, and we know that LSTM is a special kind of RNN